so like I said, I can do that, although I will start on networks next week, which is for exam 2. It won't be on the exam. But like I said, I don't really have any more to tell you about probability. If you'd like to take a little more time to allow it to sink in, I will entertain that idea. So let's say next week, 2 weeks. Votes. 4. 2 weeks. 3. Looks like we have an abstention.
I thought there was 8 people.
You don't care. Okay, Kyle doesn't care. So abstaining. 1. Okay, it looks like we're going to do it next week.
Thanks, Kyle.
That's right, it's all Kyle's fault.
Well, what we have done
New nickname, Florida.
That's funny because it's from Alaska.
What would we have done if it had been tied? I would flip the coin probably. I'd use my handy random number generator. I don't know. But it wasn't, so we'll do it next week as planned. So going back to that then, when would you prefer to have a review session? I will do it on Tuesday evening.
Well, there's a class in here until 6:30 on Monday.
Are they meeting Monday?
Yes.
They are meeting Monday.
That's
In which case, oh, that's right, she meets in here. Well, we'll just meet them in another room then at 5. Down at next door, down 103, doesn't matter.
Well, I'll be in here.
Okay, so 5 o'clock on Monday? Okay, if I, for some reason, am not here, I will be here as quickly as possible. Because like I said, you never know with dental appointments and such. But I think he closes at 5 and he probably wants to go home as much as everybody else. So I will be here at 5. All right, so 5 o'clock on Monday. And since Morgan's going to be in here, we'll probably go next door. That'll be the easiest. We'll go to 101. Unless there's somebody in there that kicks us out, then we'll go down to 103. We'll make plans. Project. First of all, let me show you. I love using this thing. I don't know why it's so much fun, but it is for some reason. It's the small pleasures. This thing is the System Safety Analysis Handbook. You can see how big it is. There are probably at least 100 different techniques in system safety outlined in here. There's a fair amount of redundancy. So what I tried to do is pick out ones that, number one, I'm not going to be talking about, and number two, are not just redundant with something that I've talked about in this class or another class. So for instance, technique for human error rate prediction. I talk about that in human factors. So I didn't want to include it in this. Actually, I could have. You're not taking human factors till next year, are you? Is that true? Mm-hmm. Yeah. So I could have included that. Think about that. Anyway, what I did is I tried to pick things out of here that would be helpful to you and generalizable and not redundant with something else. So that's what I did. I took, and what this book gives you is a very brief overview of each one. Here you can see some of the list of techniques. Starting over here, you have something like, can you see that? Or it doesn't look like it's legible. Yeah. The U.S. government approach to safety analysis. And we have a whole bunch of techniques there. Process safety management down below. Process safety management section. And that goes on and on. But then finally we get to I managed to lose my place here. Since this is loose leaf, I hope nobody borrowed this from me and didn't return it. Oh, here we go. Summary list of techniques. That's what I was looking for. Okay. Here we have a whole bunch of list of techniques. And some of them are kind of, like I said, they don't look redundant, but when you go actually looking at the technique itself, it's repetitive with something else. It's only a slight variability. So let's take a look at the one for fault tree analysis. We're going to be doing fault tree analysis in class. Okay, so that one is on 3-125. What the summary gives you is the title and any other names that it might go by, any aliases, what the purpose of it is, a very high level overview of the method, how to apply it, what they call thoroughness, in other words, limitations and such. And most importantly, it gives you some idea of the symbology and an example of a fault tree. And this is more detailed than many of them are. And it gives you a list of references at the end. And that list of references, I think most of you will find helpful as a beginning to doing research on your topic, using that list of references. So what I did is I scanned in each one of these, and I'll send them to you individually for the technique that I've assigned to you. That'll be a beginning for you. And the schedule here, and what I'm going to do is this was a prelim. Oh, sorry. Actually, before you look at it, let me review who I gave what to. I'm fudging it. That one is, I think this will be a better set here. Like I said, I'll send it to you, so don't worry about it. This is just to show you. Root cause analysis, I gave that to Kyle. Sequentially timed events plots, I gave that to Deggy. Dahlia, you got time loss analysis. Brad, you got management oversight and risk-free analysis. Vince, you got cause-consequence. Taylor, I gave you the technique for human error rate prediction. I forgot the rate, but you'll get the idea. Digraph utilization, Richard and Linda, I gave you barrier analysis. What I will do is I will send each of you an individual PDF file with the section out of that book that will get you started on it. And like I said, what I want you to do is give us a really thorough, generalized explanation of how to use the method, what it means, how to use it, and then once you've showed us a generalizable way to use the technique, tell us whether there's software available out there. If you can get some software, even if it's just a trial version of it, bring in your PC, your laptop, plug it in here and give us a demo. Or if it's web-based, just log on here and use the web. But do some research into any software that might be available to do your technique. And then try to find a good example, or make up an example. But just make it substantial, don't make it trivial. Okay? Give us a substantial example of how to use it and that demonstrates its use. Okay? Like I said, I think it would be hard to do this in less than 30 minutes. Around 40 or 45 minutes, because there's 8 of us here. I'm going to start getting a little antsy, and I'll get out the big hook and start trying to pull you off the stage. I usually don't have to do that. It's usually the opposite problem, but don't get too worried. Except there were a couple of cases where I had to do that, yeah, but for the most part, that's not a problem. The dates for that, let's see. Everybody's written project, because you have to do a written report that you should send to me and hand to me a hard copy. Everybody has that due on the 22nd, and you won't know until the 22nd when we're presenting. So you'll be in random order, and we'll keep going on the 22nd until everybody's sick of doing it, and then we'll come back on the 29th, which is during finals, and finish it off. Whoever we didn't get finished on the 22nd will finish off on the 29th. Let's see, there's 8 people in here. Probably we'll shoot for something like 4 each session. I think that'll be about all of our limits for listening. Probably mine anyway. Especially since I'll be doing GRPs then that Friday and Saturday. So I probably will be a blithering idiot by the end of the week. I'm not already, of course. But, so that's the plan. Any questions about it? I think it's pretty straightforward. And take a look at your information sheet, and if you don't have enough information, come and talk to me. I have some references that I can lend to you temporarily, or else you can use them and see whether they're in the library. They might have they might have a better selection than I do in my office. So, but as always, come and talk to me if you have any problems. I'll try to get you started. Okay, so exam next week by popular demand, and review session at 5 o'clock on Monday. Monday will be the 26th, and it looks like that probably Morgan will be in here. But the last time she ended a little bit early, didn't she? If she ends early, I would rather be in this room just because it's more comfortable for you guys to sit. If she hasn't finished, then we'll go next door in the uncomfortable chairs over there. And I will stay until you don't have questions. And try to ease the burden of going into the exam on Wednesday.
You'll be here Tuesday as well.
I'll be here Tuesday, but remember, Tuesday I have class from 1:25 to 2:40 and 3 to 6. So I'm not going to be around, I'm not available too much on Tuesday.
Okay.
I'll,
you don't get here earlier than that?
Yeah, I could get here a little bit earlier, yeah. If like I said, if it looks like you want me to be available on, let me know on Monday and I'll come in earlier. Other questions about the exam, about the project, about like the universe or anything else? And by the way, the answer is 42, you know. Yes?
I do have a question on this.
Oh, okay. Okay, good.
Yeah, so mainly the summary. I know how to do the top part.
Okay. Okay, so that part is obvious, the tree itself. Okay. And what?
So the bottom, the random variable, like how do you get all those from the bottom?
The random variable, I could have defined it in the opposite way just as well, but the random variable was the number of successes. Okay, success probability was 0.3, or was it error? Actually, I didn't say. Let's say that it's the probability of success is 0.3. I'll just make it easy. So this is 3 successes. That's P to the third. This is 2 successes. So 2 P's, 1 success, and 0 successes. Okay. The way that I came up with the coefficients then was to take 3 objects, take them 3 at a time. So 3 objects, take them 3 at a time, 3 objects, take them 2 at a time. Since it's 3 successive trials, 3 is always the total number of objects. 3 objects taken 1 at a time, 3 objects taken 0 at a time. And so 3 the 2 and 1 end up being the same number, and they're kind of complementary. Does that help at all, or is it
Yeah,
still, it does?
I wrote it down where you had 3 over 3, 3 over 2 for the second one, and I didn't know where that came from.
Okay, yeah, that's where it comes from the number of events of interest, in this case, the number of successes. Out of 3 trials, there were 3 successes. Out of 3 trials, there were 2 successes. Out of 3 trials, there was 1 success. Out of 3 trials, there was 0 success. And those are the combinatorics associated with each of those. Okay.
And then the probability path is just multiply all the way across on the tree?
Yeah, we multiply the path probability times the coefficient to get that. So the path probability times 3 is 0.189. This path probability times 3 is 0.441. This path probability times 1 is 0.343. Those then are the ones that you check your arithmetic to make sure that that adds up to 1. Okay? Yes, Richard.
How many questions on the exam?
I think I have 14.
With no subpart. Well, one does have a couple subparts, but it's trivial.
So silly.
Yeah. In my best estimation. And my credibility, I know, is very low at this point.
Can you repeat the coefficients portion of that?
Sure. If we have 3 successive trials, and our random variable is 3 successes, which is p in this case, then to get the coefficient, you get 3 objects taken 3 at a time.
Oh, right.
1, 3, 2, that equals 3,
Okay.
3, 1 equals 3, 3, 0 equals 1.
Thank you.
Okay? Yes.
So back to the homework. Looking at number 6, letter G. For whatever reason, mine do not add up to the same thing, and I don't have my work here.
Okay.
So can you just go through that
Sure.
portion?
For some reason, and I will stay, I'm not trying to rush anybody, I sense a reluctance to leave, so I'll stay as long as you want me to. So while I'm waiting, tell me again, it was the homework on probability, which question?
Question 6, letter G.
6G. The probability of the 4th failure will occur on the 8th flight. Pascal or negative binomial, right?
Yes.
Okay. Okay. There are 8 trials, 8 flights, and the number of successes is 4. And the probability of success is 0.06. Okay. Does that make sense so far? And so the number of failures is also 4. And so we take the number of failures to 4 times the number of successes to the 4th. And as if you recall, and then multiply that by the combinatorics of 8 minus 1 over, or 8 minus 1 objects, 7 objects taken r minus 1, which is 4, 7 objects taken 3 at a time. So this is kind of a foolproof one because even if you mix up P and Q, the exponents are the same. So that would be 7 objects taken 3 at a time, 7 factorial over 7 minus 7 minus 3 is 4 factorial, 3 factorial. So this is 7 times 6 times 5 is 4 factorial. So that goes away. And that's 6, that goes away. So 5 times 7 is 35. And P is 0.06 to the fourth, and 0.96 to the fourth, and that should come up to the probability that we're interested in. And 0.000354.
It might have just been my math, and I got 45 on
Okay. Okay. It was probably just fat fingering.
And that last one's 0.94.
Oh, 0.94.
0.96, just one minus.
So would this be another one where your successes, your Q would be your object of interest, not necessarily successes?
That's right. P is the object of interest.
Okay.
And I'm just, because overwhelmingly the textbooks call it success failure, I'm just being consistent with them. But like I said, if you consciously go through and whenever you see success, replace it with event of interest, then you'll probably find it easier. If you don't have questions, you're welcome to leave. If you do, I will stay until I answer them. Okay?
What should we get on these graphs?
Oh, those graphs. What I'm trying to illustrate on those, the question was about my CDFs and PDFs for the gamma and Libel distributions, which seem rather esoteric. And what I'm trying to show you is the effect of the shape and scale parameters because what I did here is I kept the shape parameter the same, but I changed the scale parameter, lambda. And if you keep the shape parameter the same and change the scale, you can see that as you increase the scale, it pulls the distribution more towards the origin. Over here, I increased the shape to 3, and I did the same thing with the scale, 1, 2, and 3. Again, it pulls towards the origin. But the shape shifts as we increase the shape factor from 1 to 3 to 5 to 7. It pulls it out towards this direction. Okay? It's just how those two variables affect the shape of the PDF. And the same thing, I did exactly the same thing with the CDF. The CDF, I kept the shape and the scale, and as you increase the scale, it pushes it more towards this corner. Likewise here, but again, the shape factor pushes it out towards the positive direction of the x-axis. Sort of the same thing. That's for gamma. And then I went to the Libel, and you have a similar result. Shape alpha and scale beta, as you adjust them, as you adjust the shape factor, it sort of pulls it in that direction. But in this case, what it does is it pulls the height, it adjusts the height of the distribution. But as you adjust the scale, beta, that pulls it. It sort of flattens what the curve already looks like, and flattens it. And for the CDF, same thing. I was just illustrating, like I said, as you consistently change. This is less than 1. This is 1, which is exponential. This is greater than 1. This happens to be Rayleigh, and this is a shape factor of even greater than that, which doesn't have a name. And as you change that shape factor, it goes from this cumulative exponential type of shape to a shape that is more of a late failure type of a shape. This particularly right here, this would illustrate a late failure in the bathtub curve.
A lot of the practice problems, or most of them, are numbers. Is there going to be an emphasis on theory on the exam as well?
Of my 14 questions, there are 2 that will require you to write a short paragraph. Yes.
Can you give us more practice problems to solve?
I believe I might have some that are, if you are already written. Looks like I did a supplementary set here at one point or another, so that I can have them in my back pocket and see what they are. Well, let me close out it if you want to know what's going on. There we go, supplementary. Yeah,
Could you email us those?
yeah.
That'd be great.
Would you
Sure.
send me an email, remind me to do it, Becky, since you asked for it. I will be glad to send out the supplementary set and my solutions. So just remind me, and I'll do that tomorrow sometime.